You are standing in a quiet room and it happens. Your gut makes a sound. Your face goes red. You make a mental note to see someone about that. Here's the thing though. That sound is not a problem. It is your gut running a cleaning cycle that only works when you've stopped eating. The moment you try to fix it, you are actually breaking something that was not broken. And that is the situation with all 7 signs in this video. Your body has been sending you messages for years, and most of those messages got misread as symptoms. 3 things you will walk away knowing. Why the embarrassing signals are the ones you should never silence, what it means when those signals stop, and which 7 signs confirm your biology is working right now, not slowly failing. Let's start here, because someone has to. The average healthy person passes gas somewhere between 14 and 23 times a day. Most people have no idea. The ones who do know are usually horrified by it. Your large intestine is home to roughly 38 trillion bacteria, and when you eat fiber, those bacteria ferment it and produce gas as a natural byproduct. That gas has to go somewhere. The only question is when and, unfortunately, where. A 2021 review in the journal Cell, Host, and Microbe confirmed that higher gas production directly associates with a more diverse gut microbiome, and gut microbiome diversity is one of the strongest predictors of long-term health ever measured. So, if you are the person clearing the room, your microbiome is thriving. Congratulations, in the most awkward way possible. The people who should actually be concerned are the quiet ones. Very low gas output typically signals a fiber-depleted diet with starving gut bacteria, or gut motility so impaired that fermentation is barely happening at all. Neither of those is a situation you want. Suppressing gas is suppressing proof that your microbiome is alive and working. Your calf fires on its own. Your thumb pulses 3 times and stops. A muscle somewhere in your back does something you did not ask it to do. Most people search this at night. The results are not reassuring, and the panic tends to arrive before the context does. Those involuntary firings are called fasciculations, and they happen when individual motor units inside a muscle discharge spontaneously without any movement command being sent. Think of it like a computer that is still processing after you've closed the program. Your nervous system has been running hard, and some signals are leaking out during the cooldown. A 2019 paper in the journal Muscle and Nerve found that benign fasciculations are significantly more common in active, well-exercised nervous systems. Athletes get them far more than sedentary people do. The motor neurons are recalibrating after use, and the twitch is the sound of that recalibration. The situation worth actually investigating is specific, one muscle twitching persistently for weeks, alongside noticeable weakness or visible muscle loss. Outside of that, a spontaneous twitch is just your nervous system confirming it has been put to work today. You stand up and your knees pop. You roll your neck and someone in the room physically recoils. You've learned to do this quietly, in private, like a bad habit. Most people assume cartilage damage. They hear the sound and picture bone grinding on bone, something quietly falling apart in there. Here's what's actually happening. Every joint in your body is filled with synovial fluid, which is essentially the lubricant that keeps moving surfaces from grinding. Dissolved inside that fluid is carbon dioxide gas, and when a joint moves through its range of motion, the pressure change causes that gas to form bubbles and collapse almost instantly. That collapse is the sound. Research published in PLAS ON in 2015 used real-time MRI imaging to watch this exact process happen in knuckle joints, and the verdict was straightforward. No bone contact, no tissue breakdown, just gas doing what gas does when pressure changes. The joints worth worrying about are actually the quiet ones. A hip that has been locked in the same position for years. A thoracic spine held rigid by years of desk sitting. Those joints are losing mobility in silence. The cracking joint is moving. Movement, as it turns out, is the whole point. Not because you're hungry, not during a meal. In a silent room at the single worst possible moment, your gut announces itself to everyone present. Most people reach for a snack to stop it. That's exactly the wrong move. Every 90 minutes when there is no food being digested, your gut runs something called the migrating motor complex. It's a coordinated wave of muscular contractions sweeping through your stomach and small intestine, pushing out leftover food particles, bacteria, and debris that have no business lingering in there. Your gut is cleaning itself, and the growl is the sound of that cleaning cycle moving gas and fluid through an empty system. Here is the catch. The migrating motor complex only activates when you are not eating. Snacking every hour, grazing constantly, never letting your gut actually empty, these habits block the migrating motor complex from ever running. Research from the University of Michigan Gastroenterology Department links impaired migrating motor complex activity to small intestinal bacterial overgrowth, chronic bloating, and accelerated gut permeability. Your gut growling between meals is the maintenance mode running. Eating to stop it is switching off the maintenance. You finish a meal and your fingers cool down. Maybe your nose goes slightly cold too. You check if you're coming down with something. Your nervous system just made a deliberate decision, and it made the right one. Digestion is expensive. Your stomach and intestines need a significant increase in blood supply to break down food, absorb nutrients, and move everything forward correctly. To provide that, your autonomic nervous system temporarily redirects circulation away from your hands, feet, and skin surface and routes it inward toward your digestive organs. Less blood at the periphery, more where it is actually needed right now. A 2020 study in the American Journal of Physiology confirmed that healthy individuals show measurable peripheral vasoconstriction after eating, and that this response is a direct marker of a properly functioning autonomic nervous system. People running in chronic stress or eating while distracted often never experience this shift at all. Their body will not authorize the switch into rest and digest mode, and their digestion pays the price. Cold fingers after eating is your autonomic nervous system doing the job it was built for. You step outside and sunlight lands on your face. Before a thought forms, you sneeze, or someone flips on a bright overhead light and your nose responds before your brain has even caught up. This confuses people. Light and sneezing have nothing to do with each other, so why is your nose involved? About 25 to 35% of people carry this response, and it has a formal name, the photic sneeze reflex. Research published in PLOS Genetics in 2010 identified the genetic basis. The optic nerve, which carries light signals, and the trigeminal nerve, which handles facial sensation, including nasal irritation, run in close proximity through the brainstem. In people who carry this variant, a strong surge of light through the optic nerve cross-activates the trigeminal nerve. Your brain receives a light signal, and part of it gets interpreted as a nasal irritant. So you sneeze at sunlight, entirely genetic, passed directly from parent to child, and a sign that your cranial nerve pathways are tightly wired and responding fast. It accomplishes nothing practical. It just means your nervous system reacts at speed, which, all things considered, is not the worst thing to have going for you. You see someone yawn. Within seconds, your jaw drops. You feel embarrassed and try to cover it up, like you've been caught doing something rude. Contagious yawning has almost nothing to do with being tired. It's driven by your brain's mirror neuron system, the network that fires both when you perform an action and when you observe someone else performing the same action. These neurons are the neurological foundation of empathy. When you watch someone yawn, your brain activates the same motor pattern it would use to produce a yawn itself. A study from the University of Pisa, published in PLOS One in 2011, found that contagious yawning frequency correlates directly with scores on validated empathy assessments. The higher your empathy, the more reliably you catch yawns from other people. People with antisocial personality disorder showed significantly reduced susceptibility, consistent with impaired mirror neuron function. The person who catches your yawn and looks mortified, their social brain is working exactly as it should. The person who watches you yawn and feels absolutely nothing, worth keeping an eye on, maybe. You're back in that quiet room. Your gut makes a sound. Your face goes red. You came into this video treating your own body like a list of complaints to fix. Every pop, every twitch, every growl was another item to Google at midnight and quietly worry about. None of it needed fixing. 7 signs that read like problems. 7 signs of a body running its cleaning cycles, recalibrating its neurons, lubricating its joints, redirecting its blood supply, and wiring itself for empathy. A body that is doing all of that is not in decline. It is at work. The one worth worrying about is the body that goes quiet. 38 trillion bacteria working. Yours are still talking.